or enthalpy. Enthalpy is denoted by H, capital H, and you can also consider heat content and enthalpy are same, but it is not always. We'll come across in the coming lectures. This is not always, but most of the time heat content is nothing but enthalpy. Okay? Of the molten metal pig iron, if you remember, we have discussed the production of iron. So, in the production of iron, that iron is basically called which iron? Pig iron, and that will often in form of molten state. Fine? And we also get slag also, if you remember. Molten pig iron and slag, molten slag. Right? So, this production of iron is a continuous process. We are continuously feeding raw material and we are continuously withdrawing the molten pig iron from the reactor. It is a continuous process. It will go up to 15 to 20 years continuously without any stoppage. Right? It will continue. Right? So my point is, when you collect, suppose that process is called tapping technically. Metallurgical word is called tapping. Tapping means removing the molten metal or molten slag from the furnace. It is called tapping. When you go for any internship, you come across this term. We are tapping the hot metal. That means we are withdrawing the hot metal from the furnace, or we are taking it out. Right? So if you tap 100 tons of pig iron, and if you tap 1 ton of pig iron, right? So what will happen to the total heat content in this both? Can you compare? You tap 100 ton of pig iron in one ladle. That is actually technically called ladles, where we keep the molten metal. And in another ladle you tap only 1 ton. So what happened to the total heat content in both? Different, very good, of course different, right? So total heat content will be higher in 100 ton, but total heat content will be very less in case of 1 ton. So that means this heat content or enthalpy is dependent or is independent now? Dependent on the quantity. So this will become now extensive property. Do you understand the point? So total heat content or enthalpy depend upon the quantity. So enthalpy is an extensive property. Do you understand or you understand my point now? If you take 100 ton, 50 ton and 1 ton. So what will happen? 100 ton will be having maximum heat, total heat content, then less will be 50, then very less will be 1 ton. So because we will come across this term. After coming lectures we will come across this enthalpy. Okay, so enthalpy is basically a extensive property. It depends upon the quantity of the sample or the mass of the sample. It is fine. Now this is tapping temperature. Suppose you are tapping pig iron and temperature is 1450 degree or 1500 degree centigrade. Pig iron temperature, right? And composition. If you remember the composition of pig iron, I discussed. It contains impurities. Apart from iron, it has impurities. Carbon will be there, sulfur will be there, silicon will be there, phosphorus will be there. And we have discussed an example of phosphorus removal. Right? Okay. So if I will consider only chiral relativity. Carbon weight percent. Suppose maybe 4.3 weight percent. Okay. The percentage of carbon in that pig iron is 4.3 weight percent. So same example. You tap out 100 tons of pig iron and you tap out 1 ton of pig iron. So what is the temperature in that and what is the temperature in that? Will be same or different or what? He is right. The temperature will be same. At that moment, I am talking at that moment only. Because if you allow it to stay, some heat dissipation will be occur. And heat dissipation will be occur fast in the small amount of material. It will become cool. Because heat content is higher in 100 ton. Right? But heat content is lower in this. So heat will be released fast in this. Okay, anyways, you understand my point? So if you measure the temperature of 100 ton of molten pig iron and 1 ton of pig iron, it will be same at that moment. Okay? So that means temperature is which property now? It is independent of the quantity, it is intensive property again. So temperature, so you may get a question like this. So temperature is dependent or independent, it is extensive or intensive property, justify it by giving a suitable metallurgical example. You can give this molten metal example. Do you understand my point? Right? Similarly, composition, carbon composition. Can you tell me now 100 ton of molten pig iron carbon composition and 1 ton of pig iron carbon composition? They are same or different? Who is saying same and who is saying different? And how many of you are saying it will be different? Just use the mind at least. Everybody understood the temperature, how it is independent of the quantity. Now the next example is the composition. I have given a simple example, that is carbon present in the molten pig iron, right? So my question was 100 ton of pig iron carbon composition and 1 ton of pig iron carbon composition will remain same or will be different? Who are saying same? 1, 2. Are you sure that you are confused? Just think again. Same or different? Same. Same. It will remain same. So that is why this is very interesting. What I am giving a real situation. During any metal production, listen carefully. During any metal production, quality is a very important phenomenon, because you cannot sell any material to the customer. Customer has a particular demand. We need this composition material. It should not divert. It should be plus minus 0.001 maybe, but it should not be like plus minus 1 weight percent. Nobody will buy your material. You understand my point? So quality is very important, and quality depends upon composition. For example, quality means suppose about property. Property is also affected by composition. You have to remember. It doesn't affect by only structure. Property also depends upon composition also. If you change the weight percentage of carbon in steel, the hardness and the strength changes. You have to remember this one. Don't always think that if I change the structure, property will change. You can change the property by changing the composition also. The best example is the mild steel and high carbon steel. Mild steel means less carbon. It is less harder, less stronger. But if you consider a high carbon steel, it is very hard. Okay, it is very brittle also. Anyway, so my point is composition is an intensive property. It will independent of the size or quantity or mass of the pig iron layer. Okay? Why? Why? But how we calculate weight percentage of any impurities or any material present in the element, for example? So iron and carbon are there. Right? So how we calculate the weight percentage of carbon and weight percentage of iron? How? Can you justify it? Yeah.
Weight of carbon and total weight of the material.
So the simple concept is whatever amount of material you are taking, that is 100 weight percent. If I am taking 1 gram of pig iron, that is 100% now. You consider that is 100%. So from that 100%, some part will be iron, some part will be carbon. Okay. If you are taking 100 ton of pig iron, that is also 100%. That means if you add the elements, that should be 100 weight percent. You understand my point? Suppose I am taking 200 ton of pig iron now. So it contains iron and carbon only. So if you add the weight percentage of iron and weight percent of carbon, that should be equal to 100 weight percent again. Whatever amount of material you are taking. You understand my point? Suppose you are talking about iron, carbon and sulfur. So that means weight percentage of iron plus weight percent of carbon plus weight percent of sulfur should be equal to 100 weight percent. Whatever amount of material you are taking. If you are taking only a 0.001 gram of pig iron, same carbon will be there, same iron will be there, same sulfur will be there. Because that 0.001 gram is considered to be 100 weight percent now. Okay. Because these are the constants which will make the final material now. Because that pig iron is made up of iron, carbon, sulfur now. You understood my point? So that is the reason why composition is also a intensive property. It will independent of the mass of the sample. Basically, there is a instrument called XRF. I have used that during my research. That is called X-ray fluorescence spectroscopy. That instrument will give you the readings. How much weight percentage of different elements are there. And there is another instrument called ICP OES also. Inductively coupled plasma optical emission spectrometer. Industry people use this instrument. OES also there, optical emission spectrometer. We'll not go into that. Just remember, sometimes you may come across these words. Optical emission spectrometer, XRF, X-ray fluorescence spectroscopy. Okay, anyways, now up to this it is clear. Temperature is intensive, composition is also intensive. Okay. Mass and volume are extensive. Next, volume fraction. Okay. Total. Okay. This is again interesting. You people know what is the gear in our motorcycle or car? Have you seen what is the gear? Gear, if you have a bicycle, for example, in the back side there will be a like ring kind of structure. You see, having teeth. The chain is attached to those teeth. No? When that gear will move, it will move the chain and it will move the tires and it will move finally. Okay. So actually those gears are made up of steel basically, and there is a processing. There is a processing called heat treatment. You will come across during during 6th semester. I guess. There is a subject called heat treatment. So we give a heat treatment, that is one kind of processing to improve the property of that gear. Because gear will not happen. Gear is always rotating, right? And if it is a motorcycle or if it is a car, it should rotate at a very high RPM, revolution per minute. And chain is there, so what will happen? There will be some tear will be there, some wear will be there. Due to friction, some material loss will be there with time. You understand my point? Your gear will become reduced in dimension. So the teeth will be just become flattened with time. Okay, due to removal of material from the surface. Okay, with time. But you don't want that, huh? You want it should be staying for more duration of time. You should not change the gear frequently. You can change a gear for maybe after 10 years or 5 years. You cannot change it in 1 year or 2 years. You understand my point? So that means it should have very high hardness. This is a very important property. Hardness is a very important property. So hardness depends upon structure again. So there is a particular phase in the steel called martensite. Technically it is called martensite. If a steel is having martensite structure, it will become very hard. And once the steel becomes very hard, it will be not getting wear. There will be no loss of material from the surface easily. That is actually technical called wear resistance. So resistance to wear will be improved if martensite will be there. Martensite increases the hardness. So what basically we do? We produce a gear and we put it into water directly from hot condition. From high temperature, like from 1000 degrees centigrade, we will suddenly put it into the water. That is called quenching. Have you ever heard about this term quenching? I may be in the school days. Quenching means very fast or very rapid rate of cooling. 1000 degree to water. You can imagine suddenly. So that means what will happen? A structure will come out in the material. Because steel is very important material. It shows different structure. So martensite will form. Initially there will be no martensite. There is a phase called austenite actually. Ma'am have started about talking about FCC structure, phase center cubic. Austenite is actually phase center cubic structure. Each phase has a crystalline structure. So austenite phase will be there at high temperature 1000 degree, that is phase center cubic. The moment is quenching, FCC will become BCT, body center tetragonal. You have to remember this term. The crystal structure changes. If you remember, I told you now, if you change the temperature, crystal structure can be changed. Okay, and if structure will change, property will change. So how the property is changing? Because you are forming a martensite. Because martensite is body centered cubic. But earlier it was FCC, phase centered cubic. Okay, that is called phase transformation. Phase is changing with temperature. From high temperature phase is FCC, very low temperature, sudden rate of cooling and low temperature phase is BCT here now. Body centered tetragonal. Martensite form. It becomes very hard and brittle. So basically gear are given this kind of treatment. My point. Now, if you take 100 kg of gear, you make just imagine an ideal situation. You make a 100 kg of gear and you make a 1 kg of gear. In both cases, you are doing quenching. Both are martensite now. So, can you tell me it is an intensive property or extensive property? The first total amount of martensite in both cases are same or different? Different, very good. If you see the total amount of martensite, it will be different actually. 100 kg of gear will be having more martensite. I am asking about quantity now. Once quantity means it is extensive, of course. Okay? So total amount of any phase is an extensive property. But the moment I will say volume fraction of martensite, because you will come across during physical materials this term, volume fraction. Volume fraction is very important because you can have two different phases also. In a material, you can have two phases. One phase may be soft, one phase may be hard. Listen carefully, this is very important. Suppose ferrite, I am talking about, there is a phase called ferrite. In steel we have a phase called ferrite. Ferrite is body centered cubic, BCC, crystal structure. Martensite is BCP. So if amount of ferrite will be more, martensite will be less, then the amount of ferrite will decide the property. Because its amount is more and it is a very soft phase. Martensite is a very hard phase. You understand my point? Suppose another steel you have where martensite amount is more, but ferrite amount is less. Ferrite is soft, martensite is very hard. So overall property will be very hard. So that means the volume fraction of a phase also decides the property. Do you understood the points? So there is a concept called volume fraction of martensite now. Can you tell me, volume fraction of martensite will be intensive or extensive? Like total amount of martensite is extensive. Okay. Intensive. Fraction now, divide. You have to divide. So volume fractions means amount of that phase divided by total amount of other phases, or total all phases. Suppose for example, you have a phase called alpha and you have a phase called beta and gamma and suppose delta. These are the phases. You want to find volume fraction of alpha. So what you can do, take alpha, amount of alpha, divide by amount of alpha plus beta plus gamma plus delta. Right? So here you can say volume fraction of martensite means amount of martensite divided by total volume of the material here, or total amount of total volume of the material in simple way, because there is only single phase, but if multiple phase will be there, this is the volume fraction. You want to find out volume fraction of beta then. So amount of beta divided by total amount of all the phases. You understood or you have any confusion? So now this volume fraction will become intensive. It will be independent. You take a 1 gram of steel, 1 gram of gear, you take 100 gram of gear, and you find out the volume fraction in 1 gram of gear and 1 gram of or 100 gram of gear. They will be remain same. Do you understood the point now? You understood my point? If you take 100 ton of gear also, volume fraction of martensite will be also again same, but total amount will be changed. Okay, so again volume fraction is independent of the mass or quantity, that is intensity. Hardness. Now tell me, if you take 1 ton of gear having martensite and 1 gram of gear having martensite, you make it 2 gear now. You measure the hardness value. Are they same or will be different? Who are saying different? You understand my point? You take 100 gram, you take 1 ton of gear which is having martensite, you take 1 gram of gear having martensite, you measure the hardness value of both. It will remain same or different? Who are saying different? You. No, it will remain same. So hardness is this is again very important metallurgical property. So hardness you cannot change it. So hardness is again intensive property. You take any, if composition is same, listen carefully. If composition is same, volume fraction is same, right, and structure is same, technically. You take any piece of metal, smaller, bigger, or any dimension, the hardness behavior will remain same. Right? You know, hardness is a property, and it depends upon structure, and it depends upon composition. So hardness depends upon carbon here. Hardness depends upon the volume fraction of martensite here. Okay. So any piece of metal, volume fraction of martensite is same. Any piece of metal, carbon weight percent is also same. That will affect the hardness. So only the hardness will remain same. You take any piece of metal. That is the real situation we are doing when we are doing research. We are not taking the entire component to measure the hardness. Okay. We are not taking the entire gear to measure hardness. We will cut it into a small piece and we measure the hardness of that small piece. Okay. You cannot put entire specimen under a hardness machine. Is it not possible? Suppose you make that door size steel, for example, and you want to know the hardness of that steel. You should not bring that entire piece of steel and put it under. It is not possible. You cut it into a small piece and measure the hardness. That will justify the hardness of that. Do you understand my point now? So hardness this is again what? Intensive or extensive? Huh? Intensive, independent of the size, the quantity. Okay. C by A ratio. You will come across. I will teach you this one. C by A ratio. C means C is one axis, A is one axis. Okay. I have started talking about lattice parameters. I guess. Huh? What are lattice parameters? Can you tell me? Yeah. I am not asking definition. Just tell me what are lattice parameters. Don't focus on definition. You will forget it. Okay, suppose we will make a cube. So this is a cube, for example, a unit cell. Once I am talking about lattice parameter, means you have to consider the unit cell. Okay, because unit cell is the smallest unit which will justify the entire material. Property of unit cell will justify the property of entire material. That is the smallest unit possible in crystalline material. Right? Lattice parameter is this distance. This distance are lattice parameters. So this is A, this is B, and this is C. This one. Or this is A. Okay, fine. Let it be. This unit cell is repeated in 3 dimensions. So what I will do? I will bring one axis again here in this direction. Okay. Do you understand my point? So this length, and this length. Suppose this is C. Okay, this is C. Let it be. This is C. This is B. This is A, for example. So this dimension is one. This is one lattice parameter. This is one lattice parameter. This is one lattice parameter. So if it is a cube, then what will happen? A is equal to B is equal to C. Because in cube, all A's are same. So lattice parameter example is the A's length of a unit cell. Okay? A's length. No, these are edges. No, in the cube, this is one edge. This is one edge. And if you repeat this unit cell in this way, lot of unit cell you put. This is another edge. Okay? And what are other lattice parameter? Angles. What are the angles, right? This is one angle. This is another angle and this is another angle, right? Okay, we're done. So here C by A ratio will be intensive actually.